Hello everyone. In this lecture, we will understand that what is the requirement of just studying the system design. If you look into this, the first topic is that distributed system. Nowadays, what is happening? There is a large amount of data, and you can say the complexity of the application. We cannot put the whole application or data in one server. That means we have to go for distributed systems. What is distributed system? Basically, in distributed system, there are so many computers that are connected with each other. These computers are also known as nodes, and they work together, and it appears to the user as a single system. You know that if there are so many systems, or you can say the nodes, or you can say the computers that are connected, that means they are connected with the network, coordinate their actions to achieve a common goal. What are the real examples of distributed system? First, we would like to discuss that is what Google search. When you search anything in Google, basically that search is processed by different systems, or you can say the servers that are located in different data centers. Now we have to talk about what is data center. Data center, basically it is a physical facility where we can store data. That means there are there is disk storage, there are servers, and there are network equipment that are used to process your data or your request. Clear? Or you can that can store your data, and when you require that data, clear, it can be provided from those data centers. To the user, it looks like one system, but internally multiple machines collaborate to provide the result of your Google search. There are other examples also, like AWS cloud services, that is also an example of distributed system. Netflix streaming platform, Facebook social network, distributed databases such as Apache Cassandra and MongoDB. What are the different characteristics of distributed system? Resource sharing. That means what if you just what we are doing here, we are just saving the file in different systems, and when we want to find out that file, we can get the file from different systems, or you can see the servers that are present. Databases, printers we can share. Processing power of different servers can be shared by using the distributed system architecture. Concurrency, many users and process can access the system simultaneously. That means the distributed system can get can get the request from different clients at a time, and they can provide the response to those clients. Scalability, this is the number of nodes, or you can say the computers, can be added, clear, as per the demand in the future, clear, in your system. That is known as scalability. Fault tolerance, if one node fail, other nodes can continue providing service. That means you are always getting the service. Transparency, clear, it is not known to the user that there are multiple machines that are involved in processing the request of the user. The types of distributed system: client server system. Clear, in this what you are doing, there is a server, and there is a client. This client send request to the server and get the response. That is client server architecture. And example is your web browser is communicating with the web servers. Peer-to-peer systems. Clear, in this case, every system act as an client as well as server. The example is Bittorrent. And if you want to understand about the Bittorrent, how the Bittorrent works, just look at here. Basically, in Bittorrent, there is a client actually you are using that client BitTorrent or mutorrent. Clear? What you are getting? You are getting a file, that is the file .torrent file. In this torrent file, basically the data that is present, that is your file name, size. Clear? And there is trackers, address of the tracker. Now we talk about tracker. What is tracker? Clear? When there is a request from the client, clear, for just getting some file in BitTorrent, that request first goes to the tracker. And when you talk about the BitTorrent, basically this is a hybrid architecture. This tracker maintains some metadata. Clear? The server that maintains the metadata, basically that is a tracker. Clear? And what is present in this tracker? In this tracker, clear, there is a information about what are the different what are the or you can say the different parts of the file are located in which location, that is present in this tracker, that is a metadata. And basically when you just request to send to the tracker provides the address, or you can say the location of the chunks of the file that is present in different machines. Clear? And there is a concept of swarm also. Swarm means what? Different nodes that that have the what you can say the piece of that file. Clear? And after that, what happen when you when you get the location of the nodes which contains the different parts of the file. Clear? You are directly connected with those nodes. You are directly connected with those nodes. Clear? And those nodes to service your request. They provide you the data to you in the form of pieces. What is the meaning of pieces? There is a concept of pieces and blocks. Pieces basically what, when any node want to transfer the data to some another node, it transfer the data into piece. Basically the data is piece is divided into blocks, and the data is saved into the blocks. Clear? If you want to understand the concept of this, what is the requirement of BitTorrent, first we have to discuss about that. What is the requirement of BitTorrent? If we are using the client server architecture, you have seen that in network the downloading speed is suppose that 100 Mbps, and the uploading speed is 60 Mbps. That means we can download the data up to 100 Mbps. Clear? But we can upload the data up to 60 Mbps. So that means what, if we want to get the data from some server. Clear? The server can due to the limitation of bandwidth, server can upload the data up to 60 Mbps, and we are the client is able to download the data up to 100 Mbps. That means we are not utilizing our whole capacity to download the data. Clear? When we are using the client server architecture, if we are able to download the data from different machines. Clear? In that case, we can use what the whole capacity of downloading the data in our machine. Clear? That is the concept behind BitTorrent. Now, we have to talk about BitTorrent. Clear? And you have, and I think so, you have good idea about tracker. Clear? How the tracker works. What is the purpose of tracker? It provides the location of different parts of the file that is present in different machines. Clear? And when you get the data from different machines, those machines can upload up to 60 Mbps, but your system, that means you are a client, your system can download up to 100 Mbps. So that means you can use your whole capacity of downloading the data. Now we were talking about what you can say the pieces and blocks. If you talk about the pieces, basically the data from one node is transferred to another node in the form of pieces, and those pieces are divided into blocks. Suppose that the piece is 64 KB and the block is 16 KB. Now the piece is divided into blocks and it is saved into the system. Clear? There is a concept of what you can say the seeder and leechers in BitTorrent. Seeders means what? If you have 100% 100% file, or in other words you can say the size of file is suppose that 50 KB, and you have downloaded 50 KB. Now you can upload that site, that file. Clear? And leacher means what? The system, or you can say the client, those who have downloaded the file but they have not downloaded the 100% file, that becomes the leacher. Clear? And you can what think about that. If the number of seeders are more in your system, in your peer-to-peer network, what you can download the file very fastly. But the number of leechers becomes more in your peer-to-peer system. In that case, you cannot download more file. You cannot download the file in a good speed. Clear? You can just understand this one also. Now, another thing where we are using the BitTorrent. Now, BitTorrent is used to download the movies, games, as well as it is used for the purpose of patching security in among the servers. It is used in industry to patch something related to the security in the servers that are deployed, clear, in the whole system of that organization. Another thing where we are using, I think so, uh, it is also used in Facebook. If Facebook want to update some binary files, clear, by using BitTorrent, they are using BitTorrent to just update that binary file into the different servers. Clear? Now, so I think so you have understood about what client server system and peer-to-peer system, and what is the requirement of peer-to-peer system, where is peer-to-peer system is good, where client server system is good. Now the next is distributed computing system. Basically it is used for scientific simulations where computers work together to solve a computational task. And another example is cloud computing platforms like AWS, Microsoft Azure, and like that. Now the next one is distributed storage system, and in this case the data is stored among the different machines. Examples are SDFS, or you can say the Hadoop distributed file system. If you want to understand the what you can say the concept of Hadoop distributed system, basically there are two types of node. One is known as name node, one is known as name node, and another is known as data node. Another is known as data node. And the data that will be saved into Hadoop file system, clear, distributed file system, basically that data is or you can say that file is divided into the different chunks, and those chunks are saved, those chunks are saved into the different machines. The name node uh, stores the metadata. Basically it stores that where the different part of the file is saved, clear, and the data is saved into the data node. The actual data is saved into the data node. Basically the name node, or you can say this is also known as master node. The master node maintains the information about what, where the different parts of the files are saved, clear, or in which data node the different parts of the file are saved. Clear? So basically name node is known as master node, and the data node is known as working node, or in other words you can say the slave node. Another one is Google file system. The concept is near about same, only name node is known as master server and the data node is known as, in this case, chunk server. Clear? And the file is divided into the different chunks, and that chunks, chunks of the file are saved into the chunk server. Clear? And the master server maintains the metadata. Clear? What is the meaning of metadata means? Metadata means what? The different where the different in which chunk server, clear, what is the particular chunk server in which the parts, which part of the file is saved, clear, that data is maintained into master server. Now advantage and disadvantage of distributed system. Advantage: high availability. That means what, if some node fails, in that case you will get the data. Scalability, that means you can add the node or remove the node when it is required in the system. Resource sharing, that means you are sharing, clear, the different machine, clear, the resources of different machine to get something, to get the response of your request or get something. Better performance through parallel processing, because you can download the file from different servers in the same time. Fault tolerance, clear. It means what? If there is some fault in one node, you can get the data from another node due to the replication that is used in distributed system. Disadvantage: complex design and management. Network dependency, because all the nodes are connected with the network. Security challenges: difficult debugging and synchronization, because there can be a clock which is different in different machines. Data consistency issues, that means if you deleted the data in one node, clear, it must be deleted into the replication node also, clear, where the data is replicated. Challenges in distributed system: consistency, keeping data synchronized across replicas. That means what we are doing in distributed system, we are just replicating the data into the different servers, or you can say the different nodes, clear. When we are changing the data in one node, clear, it must be changed into the another nodes in which the same data is present, or replicated data is present. Availability: ensuring services remain accessible, clear. That means what the service you are providing by that distributed system, it must be available always to the client. Partition tolerance, clear. You have to handle that network failures between the nodes. Clock synchronization, clear, you have to maintain, or because there are different systems that are involved in distributed system, so you have to synchronize the clocks, clear, among the systems. Fault handling, clear, it is required that you have to detect and recover from the node failures. Real world examples, those are what Google search engine, it is an example of distributed system. Netflix video streaming you are using nowadays. Amazon e-commerce, amazon.in, you are using that website, that is also use the distributed system architecture. Dropbox, cloud storage, it is used for cloud storage. Uber, clear, ride sharing platform, clear, that also uses the what you can say, distributed system. Thank you so much.